Hello, Honors Higher Algebra students. This is Mr. Johnson, and we are in the second lesson for our unit on statistics. And in this lesson, we're going to talk about graphing this one variable data that we just studied in the first lesson. So we're going to look at, as you can see, bar graphs, histograms, stem and leaf, and then box and whisker plots. Okay, so the first thing we're going to look at is the bar graph or the histogram. Basically, this is the type of graph where you show how many items fall within each category. Kind of think of it as a bin. So the number of for example, the siblings. So it's the number of people who have 0 siblings or the number of people who have 1 sibling, that type of thing. And so that's what we're going to look at with bar graphs or histograms. Okay, so we have a couple questions here to analyze our bar graph or a histogram. First, how many students were polled in each instance above? So if you were to look at, let's say, the graph on the left, so how many students were polled in the instance above, we would just be looking at the total number of each of these columns. So for example, 5 people had 0 siblings, and it looks like 10 people had 1 sibling, and it looks like 8 people have 2, and so on. So we would just add up each of those frequencies. Over here, we have a different scenario. Obviously, the length of time it takes to get to school, same kind of thing. We have 3 total people that fall into the 0 to 5 minute category. We have 9 people that fit into the 5 to 10 minute category, and so on. So remember, I talked about how it's kind of like a bin here. We don't know between 5 and 10, we don't know how many people it takes 7.5 minutes, but we do know between 5 and 10 minutes, there are 9 people that fit into that particular category. And so you would just add up each of those frequencies to figure out how many students were polled in each situation. So I'll just jot down, add up all the frequencies. Okay, how many students have 7 siblings? So we could take a look over here on the left. And the number of students that have 7 siblings would be 1. That's just the height of that particular bar, and that's pretty easy to see. Now, if we look at how many students take 7 minutes to get to school, that's completely unknown because, as I mentioned, when you're looking at these bars, for example, 7 falls in this red bar. It is not clear how many of those 9 people does it take 7 minutes to get to school. And so this is a big question mark, and it's one of the downsides of a bar or a histogram, bar graph or histogram. Okay, let's take a look at a histogram and a stem and leaf plot. So the stem and leaf plot has a lot more specific data in it. One thing that you need with the stem and leaf plot is a key, and the key just tells you what it represents from the stem and leaf plot. So for example, if you have 2, 3, that key is telling us that that means 23. So for instance, in this particular portion of the stem and leaf plot, I have 1 and then a 0, so that would be 10. I have a 1 and then a 1, that's 11. I have another 11, then I have a 12, and then a 14, and then a 15, and then a 16, and then 17, and 17 again, and then 18, and so on. So that's how my stem and leaf plot looks. The histogram, as you can see, is not very specific, but it's a little bit more visual in my mind in terms of what we're looking at. In this case, the length of time it takes to get to school. The stem and leaf gets much more specific data. So for example, between 0 and 10 minutes, there are 12 people. Well, over here in the stem and leaf, I can see exactly the time. So that's 2 minutes, and that's 4 minutes, and that's 8 minute, 8 minute, 8 minute, and that kind of thing. And so it's a much more specific approach to the same set of data. So if we're looking at how many students take 7 minutes to get to school, the histogram is not very helpful for us. But if we take a look over here at the stem and leaf plot, let me change to red, we can see that there are 2 different students for which they take 7 minutes to get to school. And on the histogram, we were unable to know that. Okay, let's take a look at the next question. It says, what is the median amount of time it takes these students to get to school? So remember, the median is the middle number. One thing that we can do is go through and say, all right, I'm going to cross off one of them. low end, and one on the high end, and the next one the low one, the next one the high one, and we can do this kind of throughout to get to our data. Another way to do this, and I did mention that technique before in lesson 1, but another way we can analyze this, if we can take a look at the total number of students that are, in this case, surveyed, about the length of time it takes them to get to school. We do have 12 here, and we have 10 there, and 3 here, and 2, and 1, and 1. So if we were to just simply total all of those up, I believe we get 29. So if we have 29 pieces of data, then we would essentially have 14 and 14 like that. That would give us a total of 28. This middle one right there, that would be our 29th data point. And so if we were to go from least to greatest, so least to greatest, I'm just kind of outlining this because if you notice, the stem and leaf is already from least to greatest. Then the 15th term right here is what we're going to be focused on. Okay, so instead of doing this kind of cross-off method, which is fine, by the way, we can instead just from one end say, okay, I have 2 and then 4 and then 4 and 5. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's my 15th data point, and you could just double check that you have 14 on the other side as well, but that's going to be my middle. So again, I have 14 pieces of data, then I have my 15th, which is my middle, and then I have another 14 pieces of data to finish it off. And that's just another way to get or organize the median. So my median here is this value, which remember based on our key means that that's going to be 11. So that is our median in this case. Okay, we will now create our own bar graph and stem and leaf. So let's start with the bar graph. And in this case, we have the scores for the freshman basketball team. So it's the points earned in games during the basketball season. And on the horizontal axes here, we'll go ahead and just put points scored, because that's what our table is showing us. And oops, sorry, points scored. And then on the vertical axes, we'll go ahead and put the frequency. All right, so it looks like maybe a good way to break this down is by tens. This is obviously something that you as the author can decide, but I'm going to go ahead and break this down by tens. And it looks like the maximum we have is looks like 51. So I'll just go ahead and do 10, 20, 30, 40, 50, and 60 like that. And so I'm going to look at how many games would fit into each of those categories. And on my vertical axes, I'll just make this a frequency of 1, 2, 3, 4, and 5, and we'll see if that will take care of everything here. Okay, so no game was between 0 and 10, so we're going to leave that little section blank. From 10 to 20, it looks like I have 16 and 18 and 12. So it looks like I have 3 of those. So I'm going to make a little bar. It's going to go up to a frequency of 3 in between 10 and 20. All right, let's erase this stuff. Okay, let's change colors and go from 20 to 30. So 1, 2, 3, 4, it looks like. So I'm going to make another bar here. It's going to go up to 4. Okay, let's go on to the next one. So we're looking at 30 to 40. So I have 1 and 2 and then 3. So we'll make a bar that goes up to 3. I'm kind of out of colors, so I think I might need to repeat. Let's go back to red. So we're going to go from 40 to 50. So 40 to 50 is 1 and 2 and 3 again. So I go up to 3. And then 50 to 60 is our last one. And it looks like we have just 1. And so we make a little bar like that. So that would be our example of a bar graph. Okay, let's go ahead and do a stem and leaf plot. So we have 1, 2, 3, 4, and 5. And we're going to look at basically just listing out all of our scores. Our key here is going to be where we have, I'll just take that game that I have circled there, that 51. So if I have 5 and 1, that key is going to show that that's 51 points scored in this particular game. So my my lowest score was 12, so that's going to be a 2 like that, because remember the 1, 2 would represent 12. And the other values within this particular line would be 6 and 8 for 16 and 8, or sorry, 16 and 18. And then I have my 20s, so I have 20, I have 27, sorry, 27, and 27 and 29. For my 30s, we have 32, 33, 34. For 40s, I have 41, 42, 48, and I have 51. So again, we're going in order there. We produce the key, and that's our stem and leaf plot. Okay, I'm assuming that you have seen box and whisker plots, but I'm going to go through the basics of them. So a box and whisker plot, or you could just call it box plot, is just another visual to display the data and to display the spread of the data and the kind of similarities between two different data sets. And with a box and whisker plot or a box plot, we're focused on the minimum, the lower quartile, which is Q1, the median, the upper quartile, Q3, and the maximum. So this right here is called the 5-number summary that you may have heard in the past. Remember, in your calculator, it is produced based on the one variable stats. So if you, for example, were to type in all this data right here, you would get the following 5-number summary. And the way we plot this is that we put the minimum, we put the maximum, the quartile 1 is the left side of the box, quartile 3 is the right side of the box, and the median is in the middle. And so you create this box right here with the median and a whisker on either side. So that's where it sort of got its name. The box represents the middle half of the data. So in other words, you have all of your data. This box would represent 50% of the data. It's the middle half of the data. The lower whisker is 25%, so this is going to be right here. This is 25% of the data fits into there, and 25% on the upper end as well. And so this is kind of an important visual to understand. If you were to take, for instance, quartile 3, anything less than it would represent 75% of the data, because 50% is stuck in the box and 25% is the lower whisker there. And so you have all sorts of ways to kind of analyze where this data is, where the tendency is for this particular data. Okay, so we're going to look at the following data set. We're going to find the 5-number summary. So what I'm going to do is I'm going to go into my stat menu, go into edit like we did in lesson 1, and in L1 I'm going to type in this data. Okay, so again, I'm going to type it in my L1. I'm going to do my calculate menu, one variable stats. You can refer to lesson 1 for all of those instructions. So the 5-number summary, I'm going to go ahead and list for you. This is going to be part A. The minimum is 2. Quartile 1 is 2.5. Sorry, that's quartile 1. The median is 5. Quartile 3 is 6, and the maximum is 9. So remember, when you do your one variable stats, you want to make sure that you scroll down, and you will see that then on your particular screen. Okay, so for part B, we're going to go ahead and do a box plot. So with a box plot, you start with a number line, and the box sort of hovers above the number line. So this number line, I'm just going to mark off 1, 2, 3, 4, 5, 6, 7, 8, and 9 like that. And I'll put in the rest of the numbers really quickly. Okay, so your box plot hovers above this line. It doesn't go on the line itself. So my minimum is 2, so I'm going to put a little dot there. My quartile 1 is 2.5, which let's say that's about right there. My median is 5, and my quartile 3 is 6, and my maximum is 9. So here's my box. I have my whisker on the left, whisker on the right, and this data just visually is showing us that more of the data is shifted sort of to the left of all of this, because remember, all of this stuff right here, so the left whisker and the box itself, that actually represents 75% of all the data, which means that this section right here is only 25% of the data. So the data is sort of trending towards the left half. It's not very balanced. It's kind of on the left side of this box plot. Okay, so next we have, for C, the range. I'm sorry. So the range is going to be the maximum, which is 9, minus the minimum is 2, so that's going to be 7. The interquartile range, remember the interquartile range is Q3, which is 6, minus Q1, which is 2.5. So the interquartile range is 3.5. And then for part D, find the percentage of data values less than 3. So we're looking at 3, and we're thinking to ourselves, okay, well, what percentage of the data values is less than 3? And in this case, that would be values that were in that sort of whisker on the left, which is, again, 25% of the data. So that's kind of back to this whole idea that 25% of the data is here, and 25% of the data is here, and 25% of the data is there, and 25% of the data is there. So hopefully you can see that as I'm highlighting it. We're looking for less than 3, which means if this little Q1 is 2.5, that means that we're looking at this set of data, which is going to be 25% of the total. So here's our next slide, and this really wasn't supposed to be in. This is just a repeat of the last problem, so we're not going to do this one. This is the exact same set of data. Okay, so in this example, we're going to take a look at 2 different bar graphs and talk about the comparisons here. And so the minimum of each is 2. The maximum of the one on the left is 8, and the one on the right is 9, so that's a little bit different. They both sort of have this natural skew to the left side, because you can notice that the box itself is sort of shifted to the left. It's not really central. The whisker on the right side, the upper whisker here, is larger in both cases, and so the data is sort of shifted. And so the first question says, on average, did the students in group A or B read more over the summer? Now, it's a little bit difficult to tell the mean because, again, we don't have the data itself, and the mean on a box and whisker plot is a little bit more difficult to analyze. And so what we're looking for here is really the median, because with a box and whisker, that is a central focus of that. And the median in this case is the same for each one. The median is 4. We can see that line right here for each group A and B, and that would be kind of our focus of where the average is. Does the following bar graph represent group A or B? So when you analyze this bar graph compared to our data here, which obviously is a very different representation, you can see that there is no bar for 9, which means that it can't be B, because B has data that goes out to 9. It has to be group A. Okay, that does it for our second lesson. And so you're going to do a little bit of homework on practicing these types of graphs, and then we will get into the next lesson, lesson 3, as soon as we're done analyzing these graphs and getting good at working with them.